Hello everybody, it's Brian and I'm going to go over some more stuff we can do categorical variable analysis in StatPowers. Under analysis there's a couple of pages I'm going to look at. First is Qualitative Two Variable. So this is commonly we kind of tabulate our data into a contingency table where we have two variables, discrete variables, which may be categorical, may be actually numerical, either way. But so the way you set this up is you create the contingency table. Let's say that we have age as our first variable, and let's say we have let's juice preference as our second variable. Let's say we preference. Let's say we have asked people 3 age groups and we have 3 juices that we ask them about. We ask them, do you prefer apple juice? Do you prefer orange juice? Or do you prefer cranberry? And we have people in, let's say we interview people who are in the 25 to 35 group. We had 36 to let's say 45, and let's say what the last was 46 plus. So anyway, that's how you can set up your contingency table, and then from here you can just put in your data, collect it however you collected it, just put in the numbers in the table. I'm just going to put some made up numbers in here. And so once you've set up the contingency table, which can actually have as many rows and columns as you want, if you put in more columns, it will just have a scroll bar that appears. Anyhow, I'm going to show you what the marginal table looks like. Marginal table is going to show you it's going to take this data and put it into, it's just a nicer format, and it gives you column and row totals. You've also got proportion totals, as I've shown in another video. But I'm actually not so interested in the marginals at the moment. What I want to look at is the test for independence. So test for independence, it is going to perform a chi-squared test. So this is going to give you another table. Here, I'm going to change my frequency. So what it's doing is showing you if the variables were independent, then what you would expect to see was each cell of the table should be proportional to like the product of the row proportion times the column proportion, right? So that's how you would calculate out of the total. This gives you the expected numbers for each of them, and it calculates the chi-square statistic, which is based on that, and a chi-square distribution based on the number of rows -1 times the number of columns -1. So it's 4 degrees of freedom. Anyway, it's giving you a p-value, which the thing you want to ask yourself is, are the column and row variables independent? If your p-value is low, lower than your significance level, which may be 0.05 is kind of your go-to significance level, then you would conclude that there is a dependency. You can see that my p-value is 0.552. So even though I just made up the numbers kind of out of thin air, they're not so far away from these expected numbers that I would attribute it to an actual difference or an actual dependence of the variables. It can be explained easily by just the chance of random sampling. So that's how you do a test for independence. Really, you just put the stuff in your contingency table, and you just look at the results. The next thing we're going to look at is under analysis, the goodness of fit test. Also super easy to do. Let's say I'm looking at car data, and for cars, the colors that are let's say colors that are popular, white. Okay, So let's say this is national proportions, and I go and sample some cars in the parking lot, and let's say I found there were 13 white cars, there was 14 black, there were 10 red, there was 13 blue, there were 5 green, let's say there was 9 silver, and then let's say that there were 6 cars that were other. And I want to see whether these numbers are different enough from the national average that I would say something is going on in my local, area, that people like cars with different proportion than the national average, or whether this is explainable just as like random sampling, like this kind of difference occurs from random sampling. So click Run Test, and it gives you the results of the test. So it will tell you the chi-square statistic, the degrees of freedom, which in this case it's the number of categories minus 1, and the p-value, which is calculated from the chi-square distribution. And again, the hypothesis, the null hypothesis, is that the data is drawn from the given distribution. In other words, that my data is a good fit to the distribution. The alternative is that it's drawn from some other distribution. And so the p-value is higher than any significance level anybody would use, like 0.05 or 0.10. So I conclude that, yeah, there's no evidence that suggests that there's anything different about my locality than the national kind of population. And that's how you do a goodness of fit test, and how you interpret the p-value very briefly. So it's pretty quick. It does the calculation for you very, very quickly, and it's that. All right. Well, anyway, that's it for these tests for categorical variables beyond just single proportion or two proportion tests. And I will catch you next time. Bye.